Now I just wanted to add to the previous question. Previous question, we have the vector space K3 upon polynomials of degree less than 3. We have two basics S and basic T. Basic S is a standard basics, and basic T is this one. We find the transition matrix from T to S and from S to T. Okay, and the transition matrix from T to S is this one. Okay, now suppose us and the transition matrix from S to T is this one. Okay, now the question, like the follow-up question for the previous one, is given it's a polynomial P sub x is a plus bx plus cx squared, which is a polynomial in the vector space P3. The question is, we need to find the coordinates of Px with respect to T and okay. Now the first one is easy. With the coordinate of P of x with respect to the standards, we call that S is a standard basics and T is this other basics. So we know that P of x is written as linear combination of vectors in S, A times 1, B times x, C times x squared. So the coordinates with respect to S is A, B, and C, right? So now we know that the one go from S to T is this transition matrix from S to T is this one. The transition matrix from S to T is this one. Therefore, we can compute the coordinate of P of x with respect to T as follows. P of x with respect to T is the transition matrix from S to T times the coordinates of P sub x with respect to S. So we know its coordinate in terms of x. We know how to go from S to T. So now we have the one in T. P transition matrix from S to T is this one. Coordinate is this one in S. This gives us the coordinates of P of x with respect to T, which is A plus 1 over 2 C uh, 1 over 2 B and 1 over 4 C. This is the coordinates of P of x with respect to T. And then we can write down P of x as linear combination. If they ask us how to write P of x as linear combination of vectors in the basics T, we can write as A plus 1 over 2 T1, the first vector in the basics T, 1 over 2 B T2, the second vector in the basic T, 1 over 4 C or T3 and C T3, the last vector in the basics T. Now we replace them by, so what is T1, T2 and T3? t of here is t. So this is just times 1, right? So just we don't even need to write times 1 here. But it's equal to a plus 1 over 2. We have t2 with 2 times x. We have t3 is a 4 x squared over 2. So just emphasize this is vectors in the basics t. So this is, and these coefficient correspond to the coordinate of p of x with respect to t.